see the problems on binomial distribution. Okay. Last class we discussed about mean of a binomial distribution, variance of a binomial distribution, mode and recurrence relation of a binomial distribution. So we'll see that problems on binomial distribution. Here it is x takes only positive values and p of x is equal to x is equal. So what we said here it is p of x is equal p of x is equal small x is equal, so here it is ncx p power x q power n minus x. So where x is from 0 to n. So here it is what we said, n is nothing but number of trials, x represents success and p represents probability of success and q represent probability of failures. In how many failure? N minus x failures, and here it is x successes, number of trials or number of experiments. Okay, so probability of this one. So and rest of the cases this is 0. So this one is the definition of binomial distribution. Here we are using that, by using that we will calculate all the problems. Okay, so now first one, the mean and variance of a binomial distribution are 4 and 4 by 3 respectively. Find p of x greater than or equal to 1. So first here it is, the important thing is we need to see that what they mention in the problem. Okay, so if you see in that, first they give mean and next variance they give of which distribution? Binomial distribution are 4 and 4 by 3 respectively. It means that mean is here it is 4 and variance is 4 by 3 respectively is nothing but first one we have to choose first one and second one we have to choose second one. Find what they asked to calculate here, p of x greater than or equal to 1. Okay, so this is the first given information we need to know that. After that we have to see that which one we have to calculate. So here if you see that mean they give, so mean is equal to 4 and variance is equal to 4 by 3, and we have to find p of x greater than or equal to 1. So first we are writing the given information in the problem. So given that mean of the binomial distribution is 4. So what they mentioned in the problem, that one we wrote it here, mean of the binomial distribution is 4. So here this mean we are representing as mu. So that's why we wrote it here it is, that is mu is equal to 4. Here we wrote in word notation and we gave here this symbolic notation in place of mean. So mean mu is equal to 4. So this is given information in the problem. And next what we know that, so actual mean of the binomial distribution we know that. So we already proved that one. So the mean of the binomial distribution is mu is equal to np. So mu is equal to np. So from these two, what we can write here is, if you see that left side mu and here also left side mu. So for that we are equating right hand terms. Here it is having 4 and here it is having np. So for that simply what we wrote it here, np is equal to 4. So from the given information and already what we know that by using these two we wrote it as np is equal to 4, and let it be given equation 1. And next another one what they give in the problem, variance they give. So variance of a binomial distribution, what they give here is 4 by 3. So that one simply we mention here it is, the given that variance of the binomial distribution is 4 by 3. But here it is in symbolic notation what we are using in place of variance. In place of variance we use as sigma square. So sigma square or var of x or v of x. So in different symbolic notations we use for variance. So v of x also we write And next var of x, so var of x, so this one also we use r sigma square. So in any one of these we can use in place of variance. Here it is, I use sigma square, so sigma square is equal 4 by 3. Now, so here it is, since variance of the binomial distribution, this one also already we proved that one. So variance of binomial distribution is sigma square is equal to npq. So here it is sigma square is equal to 4 by 3, and here it is sigma square is equal npq. So for that, simply like as previous one, we can equate right hand side terms. Here it is left side sigma square. So we can equate the terms of right hand side. So npq is equal 4 third. Okay. So 4 third. Then next, here it is npq is equal 4 third. Now we give the equation as 2. Now coming to next, here it is substituting equation 2 in equation 1. Why? Because here we are going to calculate the values of p, q and n. Why? Because for calculating p of x greater than 1, we require those things. So for that, simply what we are doing, since substitute equation 1 is nothing but np. So already we know that. So np is equal to 4. So this one equation 1. And next equation 2 is here, npq is equal 4 by 3. So npq is equal 4 by 3. So these two we know that. So from by using these two, we have to calculate n, p and q. So for that, what we are doing, substituting equation 2 in equation 1. So here it is, simply we are substituting in place of np is in place of np as 4. So 4q is equal 4 by 3. So here it is both sides 4 both will cancel, and what about remaining, q is equal 1 by 3. Now we are going to calculate p. So if we are using binomial distribution means obviously we know that the condition p plus q is equal to 1. So we know the value of q. So for that, simply we are writing p only left side and taking q into right side. Here it is having plus q. When it comes to the right side, it changes to minus. So p is equal to 1 minus q. So here it is 1 minus, already we calculated the value of q here. So q is equal to 1 by 3. So simply we substituted in place of q as 1 by 3. Now we are taking LCM for this one. We are simplifying that. For simplification, we are taking LCM. Here it is, the LCM is 3. So 1 into 3 is 3. So 3 minus 1, which is equal to 2 by 3. So what we got the value here, it is p is equal 2 by 3. So that one here we wrote it as p is equal to 2 by 3 and q is equal to 1 by 3. Next we have to calculate n. Okay, for applying binomial distribution, we require the parameters n and p. Of course, q we can get it. Okay, by knowing the value of p, we can get q, or by knowing the value of q, we can get p. So here it is, for getting n value, I am substituting p in equation 1. This is np is equal to 4. Or if you want, you can use this one also. Okay, any one of these two equations you can use for calculating n. Here I took np is equal to 4. So np is equal to 4. Here it is, I require the value of n. So for that, n I write it as this, and I took p right side of that one. So here it is multiplying. When it comes to this side, that is division. So for that, 4 by p. So n is equal 4 by p. Of course, we already calculate the value of p. So that value we are substituting in place of p. So 4 by, here the what about the value of p? So p is equal to 2 by 3. So that one we substituted here. So 4 into, when we take this one into the numerator, it changes to 3 by 2. So here it is, we are We are cancellation. We are doing cancellation. Two is a 4. So 2 into 3 6. So n is equal to how much? Here it is 6. So n is equal to 6. P is equal to 2 by 3 and Q is equal to 1 by 3. Now we got all these things, right? So now coming to next one. Next, so P we got it, Q we got it, and N also we got it. Now coming to next step. Here it is. So by binomial distribution, so this is the formula we are using here, right? So by binomial distribution, what we know that P of x is equal to ncx, p power x, q power n minus x. If you observe that in some of the cases they may mention in place of small x as small r, ncr, p power r, q power n minus r. So that one they can write, or simply in place of r we can use small x. Okay, so here it is. What we have to calculate? P of x greater than or equal to 1. So already we said this is a discrete one. So discrete distributions we are discussing here. So sum of all the probabilities is equal to 1. So by using that condition, simply what we are writing, 1 minus p of x less than 1. So which is equal 1 minus p of x is equal to 0. Why? Because this is less than 1 and p represent here probability. So in probability the values must be 0 to 1. So less than 1 here it is having 0. It negative values it doesn't exist. So now simply you can compare this one with this one. So here it is p of x is equal to ncx p power x q power n minus x. So if you see that one and this one, here it is having 0 and here it is having x. So it means we are substituting in place of x as 0. And already we know that the values of n, p and q. So 1 minus nc naught. So in place of small x we substituted 0, p power 0, q power n minus 0. So anything power 0 is 1. So for that no need to write this one. And q power n nc naught. So here it is, in place of n we substituted 6. So 6 e naught, p power 0 is 1 and q value we calculated, that q value is here it is 1 by 3. So 1 by 3 whole power 6. So 1 minus 1 by 3 whole power 6. By using calc, we can calculate this one 0.9986. And here the very important thing is, so we can calculate this p of x greater than or equal to 1 in another case, another form also. How to find that one? Here it is. If you see that, so 1 minus p of x less than 1 we wrote it here. So if you want you can write this one as in another way. So how to write that one? So here it is, p of x greater than or equal to 1. So it means, so minimum 1, so minimum has to be 1 and more than that. So here it is, if we observe that one, what we know that n is equal to how much? 6. It means up to 6 we can take that one. So same this one we can write it as p of x is equal 1, so plus p of x is equal to 2 plus p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4 plus p of x is equal to 5 and p of x is equal to 6. So up to this we can write, and each and every term we can calculate by using same p of capital X is equal to small x ncx p power x q power n minus x. By using that we can calculate, so all these things, p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4 plus p of x is equal to 5 plus p of x is equal to 6. And then you're doing calculation. Okay, it's lengthy calculation. Yeah, of course we can get, but answer has to become same value 0.9986. And don't forget it, here we are calculating probability. So it means the value must be lies between 0 and 1. Okay, so same this one we can calculate, or like this we can write it that one and then we can calculate. You can follow either this one or this one. So it is the easiest one for getting the calculation part, and it takes little bit time for calculating this. P of x is equal to 1 plus p of x is equal to 2 plus and so on plus p of x is equal 6. Okay, so this is the one. Here it is. We for calculating if they mention mean and variance. Okay, next. So once again we'll see that. So here it is, mean they give, so that mean we wrote it here, mu is equal to 4, and next variance they give, so that one sigma square is equal to 4 by 3. This is given in the problem. And next, but we know that the mean of the binomial distribution is mu is equal to np, and variance of the binomial distribution is sigma square is equal to np. So by using this, simply we are writing np is equal to 4 and npq is equal to 4 by 3. So after writing these two from 1 and 2, we have to calculate n, p and q. So here I used equation 2 for getting q. So for that, simply I substituted in place of np as 4 and then we calculated. Okay. So if you want, you can use divide those two, equation 2 by equation 1 or equation 1 by equation 2. That one also we can do it. No need to follow the as it is what we discussed here. So if you want, you can divide np by npq and then we can calculate. Okay, so or just by using in place of np as 4 and then we can calculate any one of the form we can follow that. Okay, after getting the values of n, p and q, we have to calculate what they asked. And already what we said, either you can use this one or simply you can calculate p of x is equal to 1 plus p of x is equal to 2 plus and so on up to p of x is equal 6. It means you need to calculate all those things. X equal to 1 plus p of x equal to 2, 3, 4, 5 and 6. Up to that we need to calculate. Okay. Next, second problem. So here it is. Out of 800 families with 5 children each. Okay. So how many families here? Total 800 families. Okay. Out of 800 families with 5 children each, how many would you expect to have? First question, 3 boys. Second question, 5 girls. Third question, either 2 or 3 boys. And fourth question, at least 1 boy. Assume equal probabilities for boys and girls. Okay, so here it is. If you see that, so what they mentioned in the prompt, out of, okay, so out of 800 families with 5 children each, it means total they chosen 800 families. For this 800 families, how many children? 5 children. It means for each family it is having 5 children. How many would you expect to have? So how many families? So here it is, the meaning is how many families would you expect to have? 3 boys. It means 3 boys, how many families have it? And 5 girls. So each family having 5 girls, 5 children. Those 5 children, so here they are asking specifically for 3 boys, how many families? For 5 girls, how many families? Either 2 or 3 boys. It means that R is representing here plus. It means P of x is equal to 2 plus P of x is equal 3. And next, at least 1 boy. So here is the terminology is very important. At least, at most, few, better. So this is the terminology very important. Why? Because we have to write that one in a symbolic notation and then we have to calculate. So here it is, at least is nothing but greater than or equal to. So remember that at least is here greater than or equal to. So at most is nothing but less than or equal to. Okay, so at least is nothing but greater than or equal to. So it means including the, and at most is representing less than or equal to. So here it is suppose at least 1 by this side. It means greater than or equal to 1. Suppose at most 5, then less than or equal to 5. Okay, so this is the terminology very important in that. Now coming to, we are writing what they gave in the prompt. So first we are writing as given that number of children n is equal to 5. So number of children they mentioned in the prompt. So that one simply we wrote it here, n is equal to 5. Next, let the number of boys in each family is x. So just we are taking assumption is in each family boys we are taking as x. So before that, first they give one condition. What is the condition? Assume equal probabilities for boys and girls. It means that how much chances for boys, same that much of chances for girls. That one they said to assume here in this problem. So here it is. So it means we are taking the probability. The probability of each boy is equal to 1 by 2. Why? Because here it is probability is nothing but total number of favorable events, or here it is number of favorable events by total number of outcomes. So here it is outcomes are nothing but only two outcomes. What are those two outcomes? Boy or girl. So this is outcomes. So how many outcomes in that? Two outcomes. So that's why two here. And here it is we are taking event is nothing but only for boy. Okay. So only for boy is nothing but only one possibility. In the same way, only for girl is nothing but 1 by 2. So here it is, the probability of each boy is equal to 1 by 2. Since they mentioned equal probability for boys and girls in each family. Okay, so how much chances for boy? Same that much of chances for girl. Now coming to the formula. The probability distribution is, so we know that the formula here is, that formula here we wrote P of x is equal to x is equal, P of x is equal NCX, P for x, P for n minus x. And again we are saying here n is representing number of trials. Okay, and x represent here it is having success, and P represent probability of success, and Q represent here probability of failure, and n minus x failures and x successes. Okay, and the relation between P and Q is success plus failures. So success probability and failure probability is equal to 1. Okay, from this simply what we can get it here, Q is equal 1 minus P. Now, so coming to next, here it is. Next, here it is P of x is equal. X is equal. Of course, we know that the value of n, and we already know that the value of P. By using that value P, we can get the value of Q. Okay. So now we are simply substituting in the formula. So here it is. In place of n, we substituted 5, right? And next x as it is, we don't know about that. And in place of P, we substituted 1 by 2, and in place of Q we substituted 1 by 2, and in place of n we substituted 5. So in place 5, and in place of P as 1 by 2, in place of Q as 1 by 2, and in place of n as 5 minus 6. Now we, by using this, we need to calculate that one. But here it is, they didn't ask the probability. They asked families, number of families they asked. It means 800 into the respective probability we need to calculate. Okay, so here it is. Now P of first one. So P of 3 boys. So first one what they ask, we require the number of families which consisting of 3 boys. So here it is, probability of 3 boys is equal. Here it is, P of x is equal 3. So P of x is equal to 3. So that is, see here, 5C3, 5C3 1 by 2 whole cube, 1 by 2 whole power 5 minus 3. So here we see that. So this is the only we are applying here it is, right? So in place of x what we have 3. Just you can compare that. So just you can compare here it is in place of x what we have 3. So that one we are substituting. So 5c3 1 by 2 whole cube 1 by 2 whole power 5 minus 3. So here it is 5c3 1 by 2 whole cube 1 by 2 whole square. So you can use calc. By using calc we can find 5c3 and 1 by 2 whole cube into 1 by 2 whole square. So that is 1 by 2 whole power 5, that is 1 by 32, and 5c3 we can calculate by using NCR. Okay. Or simply using calculate we can find this one. So how much we got it this one? 5 by 16 per family of the probability for 3 boys. So that one we got. But they asked here number of families. How many families having 3 boys? Okay. So here we suppose that thus for 800 families, the probability of number of families having 3 boys is equal 800 into probability of 3 boys. So 800 and probability of x is equal to 3. So how much we got it here? 250 families. It means out of 800 families, 250 have families having 3 boys. Okay, each family having 5 children, but out of 5 children, only 3 boys. Okay, so 3 boys, how many families? 250 families having 3 boys. Okay, this is first question. Next, second one. Second one, what they ask? P of 5 girls. So 5 girls, or simply we can say that how many students we are, sorry, how many children we said here? 5 children. And they're asking here, those 5 children are girls. It means in another words, what we can say that there are no boys in that family. So out of 800 families, how many families are like that? Okay, how many families consisting of 5 girls? It means 800 into p of x is equal to 5. Okay, so here it is simply p of 5 girls is equal to p of no boys. That is nothing but p of x is equal to 0. So like this we can calculate. So saying this one p of 5 girls is nothing but simply what we can write, p of x is equal 5. This one also we can write. Okay, p of x is equal to 5 or p of x is equal to 0. Do you get same thing or not? See that p of x is equal to 5. It means in place of x what we have to substitute? 5. So 5c5 1 by 2 whole power 5, and next 1 by 2. Why? Because q is equal to p, both are same. Then n minus x, that is 5 minus 5. So simply what we got it, 5c5 is nothing but 1. So 1 we wrote it here. And next 1 by 2 whole power 5. This is as it is. And next 5 minus 5 is nothing but 0. Anything for 0 is nothing but 1. So simply what we got it here, 1 by 2 power 5. So 1 by 2 power 5 or 1 by 2 whole power 5. So got the same one here. See 1 by 2 power 5 and 1 by 2 whole power 5. Okay. So 1 by 32. So either you can calculate or p of no boys. Both are equal. So simply p of x is equal to 5, or simply we can write p of x is equal to 0. Here also same thing, 5c0 is nothing but 1 and anything for 0 is 1. So for that, and remaining 5 minus 0 is 5 and 1 by 2 as it is. So 1 by 2 power 5 is nothing but 1 by 32. But we require the families. How many families having 5 girls? So for that simply we wrote it here. Thus for 800 families, the probability of families having 5 girls, or simply same we can write it here is having no boys. Okay, at a time we are covering two things here. See, here it is having, if they ask 5 girls or if they ask no boys or x is equal to 0, simply you can write the same thing. So this is equal to 1 by 32 into 800. So this is equal 25 families. It means out of 800 families, how many families having no boys? 25 families. So 25 families having no boys. It means all 5 children are only girls. Okay. So this is second one. And next, third one, what they asked. Here it is. Third one, P of either two or three boys. So two members or three members are boys out of five children. So each family having five children. In that five children, two or three boys, how many families have it? So for that, simply what we are writing here, R is representing, here it is having plus. So for that, so simply here it is. So in place of R, we represent as plus. Don't forget it. This one we use the very usually this one. P of x is equal to 2, either 2 or P of x is equal to 3. So P of x is equal to 2 plus P of x is equal to 3. That is simply we can write P of 2, P of 3. So already we said, when we said in the binomial distribution, simply we write this one as P of capital X is equal to small x, or simply we can write this is P of x. So this one also we can write, or same this one we may write it as B of x n P. So like this also we are representing. P of capital X is equal to small x, or P of small x, or P of x n P. Okay. So all this we can write that one. Now we are going to calculate P of 2 and P of 3. So already we know that the formula. So what is that formula? P of x is equal 5cx. So what we wrote first one. So 5cx P power x q power n minus x, right? This is the one we are using. So here it is. You can use this formula and substitute in place of x what we have 2. So for that 5c2 and p already we know that 1 by 2. So 1 by 2 whole square, 1 by 2 whole power 5 minus 2 is nothing but 3. And next p of 3. So same 5c3 p cube q power n minus 3. So here it is, simply we wrote it here. So 5c2, so 5 minus 2 is 3 here, and 5 minus 3 is here, it is having 2. So that one we substituted. And next here it is 5c2 as it is, 5c3 as it is, 1 by 2 whole square, 1 by 2 whole cube. So that is nothing but a power m into a power n. So that one we apply. So what is the formula for this? A power m into a power n is equal to a power m plus n. So this one we applied here. Here it is 2 plus 3 is nothing but 5. So for that 1 by 2 whole power 5. In the same way here it is also same thing, 1 by 2 whole power 5. In these two terms, which one is the common one? 1 by 2 whole power 5 is the common one. That one we took common here, and 5c2 is nothing but 10. So this is simply NCR formula we can use, or calci we can use, we can get it that. So 5 factorial by, here it is n factorial by r factorial, 2 factorial into 5 minus 3, that is 3 factorial. So same, by simplifying this we get it as 10. Okay. So like this 20 by 32 per family, but we require the number of families. So for that simply what we wrote, expected number of families with either 2 or 3 boys is equal 800 into how much we got here, 20 by 32. So by simplifying that, how much we got it, 500 families. It means out of 500 families, how many families having either 2 or 3 boys? 500 families having 2 or 3 boys. Okay. And next one, at least one boy. So at least one boy is nothing but simply here it is having P of x greater than or equal to 1. So P of x greater than or equal to 1. So simply by using sum of all the probabilities is equal to 1, simply we are writing as 1 minus P of x less than 1. Or simply how to write this one? Total number of children are 5. So same this one we can write as P of x greater than or equal to 1 is nothing but P of x is equal to 1 plus P of x is equal to 2, or simply we can write P of 2 plus P of x is equal to 3. So that is P of 3 plus P of 4 plus P of 5. Okay, so all these things we can write and then calculate. Okay, we can calculate and then we get the same thing, but it takes a little bit time to do calculation of this one. Okay, so either you can use this one or this one, any one of that you can use, either this one or this one. So here it is the easiest one, simply we get it here, see that in one step. But here it is, we need to calculate P of 1, P of 2 we need to calculate, P of 3, P of 4 and P of 5 we have to calculate, and by adding all those things we will get this one. Okay, so here I applied this one. So P of x less than 1, so x less than 1 is nothing but x is equal to 0. So for that 1 minus 5 c naught 1 by 2 whole power 0, 1 by 2 whole power 5. So which is equal to 1 minus, this is nothing but 1, and anything for 0 is 1, and only remaining 1 by 2 whole power 5, that is 1 by 32. So 1 minus 1 by 32 is 31 by 32. So but we require the number of families. So for that expected number of families with at least one boy is 800 into 31 by 32. So how many then? 775 families having at least one boy. It means it may be in that out of 5 children, one boy or two boy or three boys or four boys or five boys. Okay, that is 775. You can see that we got the right or wrong. So there it is, we got it as only girls, five girls. How many families? 25 families. So 25 plus 775, that is nothing but 800. Is it covered or not? So 775 plus 25, 800. Okay, so this is the way we can calculate. They may ask different ways for the same problem. We can calculate at least one boy in place of at least one girl. Okay, or at most one girl. So few girls. So like that, terminology is very important here. If you understand the terminology, simplification is very easiest one. Okay, so these are the, this is the second one. Okay, and next one. So next one, two dice are thrown 5 times. Okay, so two dice are thrown 5 times. Find the probability of getting 7 as sum. Okay, 7 as sum. Here it is, at least once, two times, and third one P of 1 less than x less than 5. So here it is, it means previous problems directly P we got it, P equal to 1 by 2, and in previous problem also mean they gave, by using that we calculated. But here it is, first we need to calculate P and Q and N. After that we have to see all these things. Okay, so first we require the value of N, the value of P, the value of Q. So these are the three things are required for applying binomial distribution. So for that, here it is, they gave one experiment. So what the, which experiment they are doing here? Two dice are thrown how many times? 5 times. It means n already they mentioned. What about n? N is equal to how much? 5. So n is equal to 5. So this is the give. Okay. Next, what, how many dice they thrown? Two dice. So two dice thrown. So immediately we have to write outcomes. So given that two dice are thrown, the number of possible outcomes are, how many outcomes in that? 1 1, 1 2, 1 3, 1 4, 1 5, 1 6. It means on first die 1 and second die 1. 1 may appear. On first die 1 and second die 2. So first die 1 and second die 3. So like that. So here the 6 1 is representing on first die 6 and second die 1. So if you want, you can take two dice and you can see it. Okay. So first dice all 1 1 1. Okay. So second dice 1 2 3 4 5 6, and next in the same ways, this is first die and this is first die and this is first die. Okay, on first die roll number 2 and first die 3 and first die 4. Okay, so like that, total how many outcomes we got it as here 36. Okay, or in other words, already we have the form. If you are throwing a dice n times, the number of possible outcomes are 6 power n. So here it is how many dice we are throwing, 2 dice. So for that 6 square, so 6 square is equal 36. So that one we wrote it here. What are those 36 means? These things you need to remember. Okay. Now n of s is equal, n of s is nothing but number of outcomes. How many outcomes? 36. So 36 outcomes we wrote here. And now next, so next, P is equal to the probability of getting a sum 7 in a single throw of a pair of dice. Okay, what we require, what they asked here, probability of getting 7 as sum. Okay, it means first we need to find the probability of getting 7 as sum. So at least once, what is the probability? 2 times, what is the probability? And between 1 and 5, what is the probability? So it means first we require the value of P. So here it is, we have how to find the probability, number of favorable events by total number of outcomes. Already we know that the outcomes, how many outcomes in that? 36 outcomes. So for the denominator we wrote it as 36. But how we got 6 here? So what we mentioned here, what we have to choose the event here, the probability of getting a sum 7. So what are the possibilities for getting sum as 7? So here it is, if you observe this one, by adding 1 plus 1, are you getting 7? No. 1 plus 2, 3. 1 plus 3, 4. But what we require? Sum 7. So what are the possibilities we'll get here? 1 plus 6, 7. So it means 1 comma 6. And next here it is 2 comma 4. Sorry. 2 comma 5. Not this. So 2 plus 5, 7. So here it is once again. So 1 plus 6 is 7, and next 2 plus 5, next 3 plus 4, and next 4 plus 3, and next 5 plus 2, and next 6 plus 1. Okay, so it means these are the 6 possibilities, right? So what are the 6 possibilities here? 1 6, 2 5, 3 4, 4 3, 5 2, and 6 1. Do you get other than these 6 anywhere? Here is 6 plus 6 is 7. No. 6 plus 5 or 5 plus 4, 3 plus 3, 3 plus 2. Like that you can choose your own problem also here. Here they give 7. You can choose 5, you can choose 4, you can choose 3. So like that, then we can, they ask different one. Okay. So here it is in place of not only sum. Here it is they mention as product 12. So product 12, what are the possibilities we may get? Okay, here it is, product 12 is nothing but 4 into 3, 3 into 4, 6 into 2, 2 into 6. Those are possibilities, right? So these things only people learn in first unit, right? So first unit you will learn it same like this. Okay, so here it is having some 7. Okay, so how many possibilities? 6 possibilities. What are those 6 possibilities means here? 1 comma 6, 2 comma 5, 3 comma 4, 4 comma 3, 5 comma 2, and 6 comma 1. Okay, so here this we got it as 6 by 36 by cancellation of this 6 1 got, and this is 6 6 got, so 1 by 6. So P we got it. So P is equal probability of getting a sum 7 in a single throw of a pair of 5 dice. So 2 dice is nothing but simply we wrote as here this having pair. So 1 by 6. If you know the value of P or Q, we can get another one. So by using the relation P plus Q is equal 1. So by using that, simply q is equal to 1 minus p. So 1 minus p is here 1 by 6. That one we substituted in place of p. By taking LCM, what we got it here? 5 by 6. Okay, that is the value of q. Next, n already we know that. So how many times? Here it is, they said 5 times. So for that, simply what we can write? N is equal number of trials. So number of trials, how many trials? N is equal to 5. So this one already they mentioned in the prompt. Now coming to the prompt. So what they asked here, it is having at least once. Same terminology till the end of the paper we will get this one. Okay. At least is nothing but greater than or equal to. So that one we wrote. And once is nothing but 1. So that one we wrote it here. Okay, so simply what we wrote? 1 minus p of x less than 1. So by binomial distribution, what is the formula? We know that. So p of x is equal. So p of x is equal. Simply what we know that? 5cx. P power x, q power n minus x. So we know the value of n, and we know that the value of p, and n is 5. Okay. So that one we substituted here in place of x as 0, and p value already we got 1 by 6, and q value is 5 by 6. So those values we substituted here, 5 minus 0 and 0. So here it is, phi c naught is nothing but 1. So for that, here it is, phi c naught is 1, and anything for 0 is 1. So remaining is 5 by 6 whole power 5. So 1 minus 5 by 6 whole power 5, which is equal to how much we got it? 0.59. Okay, this is first one. At least. So there they mentioned 1. So we may choose as at least 2, at least 3, at least 4, at least 5. So like that you can mention anywhere. Okay. Next, here it is. Second one is exactly 2 times. Okay. Exactly is nothing but equal to. Okay. So certainty, exactly is nothing more. So that's why. So see the terminology, here it is. At least means what we wrote there, greater than. Here it is exactly. So exactly is nothing but, here is exactly is nothing but what we are writing, equal to. So these things you need to remember that. At least is nothing but, we wrote it as greater than or equal to. Exactly is nothing but, we wrote it as equal to. At most is nothing but, we have tried it as less than or equal to. Till we got these words. Okay. So until end of this one paper, we have to use the same symbolic notations in place of those words. Exactly is nothing but equal to, at least is nothing but greater than or equal to, and at most is nothing but less than or equal to. So here it is, p of x is equal to 2. Same formula we are applying in place of x as 2. So pi c2 1 by 6 whole square. So why? Because here it is having 2, and next 5 by 6 whole power 5 minus 2. So n minus x 5 minus 2. So pi c2 1 by 6 whole square 5 by 6 whole cube. So pi c2 is nothing but how much? 10. So 1 by 6 whole square, 2 plus 3 is nothing but 5. So for that 5 cube by 6 power 5. So by simplifying that, we got it as here 0.16. Don't forget it, here we are calculating probabilities. So for that we got it as, we have to get 0 to 1. So 0.16. Okay. Once if you remember the formula, and by knowing the value of n, p and q, and in board notation what they mentioned, if you write that one in symbolic notation, simply substitution, nothing in that. Okay, so this complete unit same pattern. Okay, next. Next, this is the next one. So what they mentioned here is, this is another one, right? So now we got another one, p of 1 less than x less than 5. Okay, so from 1 and 5, see carefully the symbolic notations. Okay, so here it is, suppose same this one, if they mention like this, p of 1 less than or equal to x less than 5. Next, see different notations. Here it is p of 1 less than x less than or equal to 5. Next, p of 1 less than or equal to x less than or equal to 5. Any differences between this one and this one? Okay, see that, see that here it is having p of 1 less than x less than 5, and here it is p of 1 less than or equal to x less than 5. Here it is p of 1 less than x less than or equal to 5. Here it is p of 1 less than or equal to x less than or equal to 5. Are there any differences between this one? Any difference? Here it is, if you see that between 1 and 5, not included 1 and included 5, not included 1 and 5, between those, it means simply what we got it, p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4. Only 2, 3, 4. Okay, I hope everyone knows the numbers. So 1 to 5. So between what we have 2, 3, 4. So that's why we wrote it as 2, 3, 4. And here it is, if you observe this one. So 1 less than or equal to x less than 5. It means what we will get it. Here it is, includes same 2, 3, 4. Along with that, what we will get? P of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4. Why? Because here it is having less than or equal to, including 1. Okay, suppose here it is, suppose they mentioned p of x, p of 1 less than x less than or equal to 5. Okay, so in that case, simply what we get it, p of 1 less than or x less than or equal to 5 means simply here it is, we'll get it as x is equal to 2, x is equal to 3, x is equal to 4. Along with that, what we'll get here, p of x is plus p of x is equal 5. P of x is equal to 5 means not included 1, 2, 3, 4, 5. Okay, so 2, 3, 4, 5, this total one. Suppose p of 1 less than or equal to x less than or equal to 5. It means simply what we'll get it here is p of x is equal to 1 plus p of x is equal to 2 plus p of x is equal to 3 plus p of x is equal to 4 plus p of x is equal to 5. See the differences between the, so 1 less than x less than 5 means only 2, 3, 4, only this one. 1 less than or equal to means 1, 2, 3, 4. 1 less than x less than or equal to 5 means only 2, 3, 4, 5. And r equal to 1 less than or equal to x less than or equal to 5 means all these 5. Only one thing we need to remember here, if it is r equal to there, it includes. If not there, it excludes of that particular number. Just you have to remember this. Okay, after that we know that the formula, so pi cx, pi c2, and p is 1 by 6, so for that 1 by 6 whole square and pi by 6 whole power pi minus. In the same way, next one, pi c3 1 by 6 whole cube, pi by 6 whole power pi minus 3. Next, pi c4 1 by 6 whole power 4, pi by 6 whole power pi minus 4. So see here, so this is for this one, p of x is equal to 2, and this is for p of x is equal to 3, and this is for p of x is equal to 4. So in place of x we are substituting as 2, 3 and 4. And after that we know this value of phi c2 is nothing but 10, and phi c3 is also 10, and phi c4 is 5. Next, 1 by 6 whole square, 5 by 6 whole cube, 1 by 6 whole cube, 5 by 6 whole square, 1 by 6 whole power 4, 5 by 6 whole power 1. Now we are simplifying that. 1 square is nothing but 1, 5 cube we wrote as this, and by applying that a power m into a power n plus n, so 2 plus 3, 5. Next, in the same way, here is 6 power 5, 6 power 5. In each and every term, what we have the common one? 5 by 6 power 5 is the common one. After taking the common one, so we got it as 250 plus 50 plus 5. So 305 into 5 by 6 power 5. So by simplifying that, we got it as here 0.197. So this is p of 1 less than x less than 3. Okay, so got it that one. So like this only all the problems we have. First we need to understand clearly what they mentioned in the problem. Once if you understand the question, first we have to write what the information they gave in the problem. After writing the information, which one we have to apply, and that formula we have to write. And next what they asked to calculate. So that one we have to substitute. That's it. So only one thing you need to remember here, for doing binomial distribution, we require n, p, q. These three we require for calculating that. Okay. Once if you know these three values, simply substitution of that, and along with that terminology is important. At least means what we have to use. At most means what we have to use. Next, exactly and between. Okay, so up to this we got it. Okay, and remaining we'll see next.